So we have here the black shear rupture. Okay, so the figure shows the combination of shear and tension failure. We have here the black shear rupture shown in these two illustrations of the combination of shear and tension. Okay, so if we have here a diagram, pagka meron tayong diagram dyan, pagka ito yung failure natin sa black shear. Pagka sinabi kasi nating black shear, that is a combination of the shear and tension rupture. Meron tayong tension, meron tayong shear. Black shear rupture yung tawag natin. Combination of shear and tension rupture. Okay? So pagka nag-fail itong plate natin dito, so gusset plate, pagka nag-fail yan, ito, yan. Yung failure dyan, yan yung magiging tension natin. Okay? That is the area perpendicular dito sa ating direction ng load, tension. Okay? And then, for our shear, the area that is parallel to the direction of our load, that is our shear. So, ito yung shear natin. Yan. So, kukunin natin yung area shear dyan. Yan. Okay? So, yan yung shear. That is the area that is in parallel with the direction of our load, tension load. And pagka-tension, that is the area perpendicular to the direction of the load. So pagka tinitignan ninyo, ito yung magiging tension natin, ito yung magiging shear failure natin. Okay? So kailangan nyo yan to solve for the nominal strength, the shear and tension. Okay? So we have here different pattern, black shear pattern. So I just gave 3. So for C channels, pagka ang C channels natin, nakakonect siya, ito, yung dalawang bolt natin, ang magiging shear pattern natin is this given figure. Okay? So ito yung magiging shear failure natin, dalawa yan, at yung magiging tension natin, ito naman yung tension. Okay? Ito yung shear. Shear din ito. Okay? So pagka meron naman tayong angle bar, pagka ito yung magiging failure natin sa black shear, ito yung tension natin, ito yung shear natin. So ito yung shear natin, yung yan. Shear. And then we have here the tension failure. Okay? So for the plate tension member, pwedeng ito yung failure, pwedeng ganito yung failure niya. Pagka hinila mo yan, pagka nag-apply ka ng load, pwedeng ganito yung failure niya. Ito yung mapupunit. Yan yung mapupunit. Okay? So ito yung matatanggal. Maghihiwalay ito. Mahihiwalay yan dito sa figure. Okay? So ito yung magiging tension nyo dyan. Ito yung magiging shear. Okay? So if you know where is the shear, where is the tension, you can solve for the black shear strength. Okay? You can solve for the black shear strength. But before solving for the black shear strength and the allowable strength for black shear, you need to solve first the Rn, or the nominal strength for the limit state of black shear. Okay? So what would be our equation in solving for the nominal strength of black shear? Okay, so ano yung magiging equation na natin? Okay, so the code have given this equation. The nominal strength for the limit state of black shear rupture along the shear failure path and the perpendicular tension path shall be taken as follows. So our Rn is equal to 0.6 FU ANV plus UBS FU ANP is less than Rn max. Okay? So ano ba yung Rn max? Where Rn max, nominal strength maximum natin, is equal to this value. 0.6 Fy AGV. Yung mga notation na yan, given. Yung mga definition. Plus UBS FU ANV. Okay? So that is our equation given by the code to solve for the nominal strength for the limit state of block shear. So Fu, yan yung ultimate strength, the flexural strength. Yung A and B, that is the net area subjected to shear. Yung E and B, subjected to shear. Okay? UBS is given 1.0 for most cases. For cope beam, that is equal to 0.5. Okay? For UBS. For most cases, UBS is equal to 1.0. Okay? So yung ANT natin is the net area subjected to tension. Okay? So isolve nyo ito, i-compare nyo doon sa value solved in Rn max. So paano ma-solve yung Rn max? Paano ma-solve yung Rn max? Ito yung Rn max. Okay? 0.6 FYAGV plus UBS FUAN. Okay? So yung nominal strength natin should be less than Rn max. Okay? That is given by the code. Paano pagka ang computed Rn, yung nominal strength natin, is greater than the Rn max? Ano yung magiging Rn natin? Ano yung magiging Rn natin? So Rn, if our Rn is greater than Rn max, our nominal strength now is equal to the Rn max. Okay? Kasi ito yung maximum natin. Okay? So pagka yung computed Rn natin is greater than Rn max, you have to use nominal strength equal to the Rn maximum. Okay? So pagka ang na-solve ninyo, Rn is less than Rn max, your Rn is equal to the computed Rn. Okay? Ganyan. Yung pag-solve ng nominal strength. Okay? So the design strength, yung VRN, that is for the LRFD, and for the allowable, the Rn over omega. Okay? That is the design strength VRN and the allowable strength Rn over omega. Okay? So we have now the code factor. P is equal to 0.75 and the omega is equal to 2.0. So pagka na-solve nyo yung Rn, masosolve nyo na yung design strength. Okay? Or the allowable strength of the block shear section. Okay, so let's continue. Let's have an example for block shear. So the figure below shows a plate that is 240 mm wide and 212 mm thick. The steel used is an A36 steel with FY248 MPa and Fu is equal to 400 MPa. Okay, so the effective hole diameter is equal to 22 mm. So yung given is the effective hole diameter. So that is our DE equal to 22 mm. Okay, so we have to determine the factor tensile load based on block shear. Okay, so ang hinahanap natin is the factored tensile load. So factored, given yung factored, so anong method yung gagamitin natin? That is LRFD method. Okay? Okay? So we have here the diagram for our block shear. Okay? So to solve for the factor tensile load, ano yung magiging factor tensile load natin sa LRFD? That is PU. Diba? Yan yung hinahanap. This is the required. The factor tensile load, PU. Okay? And from the code specification, our design tensile strength is greater or equal to the PU, the ultimate or the factored tensile load. Okay? Greater than or equal. Okay? So since yung hinahanap nating PU, we can say that our PU or the factor tensile load, LRFD kasi yung hinahanap natin dito since factored ang sinabi sa problem. Our PU is equal to less than or equal to phi RN. Okay? So yung phi natin, phi for the LRFD, we know that our factor is 0.75. Okay? So, kailangan lang natin yung value ng Rn. Okay? So, we need to solve for the value of Rn. Okay? So, how to solve for the value of Rn? How to solve for the value of Rn? Diba kanina, given yung equation, this is our equation for the Rn. Okay? So, but before solving for the value of Rn, you need to draw your Black-Shear path or the path wherein your Black-Shear failure occur. Okay? So, kailangan yung i-drawing yun for you to determine kung ano yung the ANV, yung value ng ANV ninyo, yung value ng net area subject to tension, yung net area subject to shear, kailangan yung i-drawing yung Black-Shear pattern diagram. Okay? So, we have here for the Black-Shear path 1. So, let's say this is the path 1. Ang Black-Shear path 1 ko, ito, natanggal yung dito. Okay? Yan, natanggal yan. Okay? So, yung red line dito, kung saan yung failure, yung red line na yan, ayan, sa taas, tapos dito sa baba, yan yung magiging failure natin sa shear. So, dyan natin kukunin yung net area subjected to shear, yung red line. Yan. Yan yung sa shear. Ito yung shear. Sa taas at sa kababa. And yan, then yung green line, yan, dyan yung magiging failure natin sa tension. Dyan natin kukunin yung net area subjected to tension. Yung green line dito, tension. Okay? So, for the path 1, natanggal ito. Ito yung natanggal. Solving for the shear and tension area. Remember, ito yung equation natin for nominal strength. Okay? Kailangan nating isolve yung A and V, A and T. So, we need to solve for the shear and tension area. And then, yung sa gross area subjected to shear, yung AGV, that is the gross area subjected to shear. Shear, hindi tension. AGV subjected to shear, A and V, that is the net area subjected to shear, A and T, that is the net area subjected to tension. Okay? So, solving for the A and T, subjected to tension, net area subjected to tension. So, ang kukunin natin, itong green. Tignan ninyo yung itong green. Ito yung tension natin. Okay? Ito yung tension natin. So, saan ko kinuha yung 120? Hanggang dito yung green line, di ba? Center to center, that is 120. Since this is 60, 60. 120 yan. Gross width, 120. Minus, ilang butas yung dadaanan niya. Ilang butas yung dadaanan niya. Isa, ito, isang butas. Full yan. Tapos, half dito sa taas, half dito sa baba. Kaya, magiging dalawa yung butas na dadaanan niya. Kaya 2. Okay? Times 22, this is the effective hole diameter, 22. Pagka ang given is the hole diameter, you need to get the effective hole diameter. Or the bolt diameter, you need to get the effective hole diameter. So this is the effective hole diameter, 22. Okay? Times 12, since area, ito yung width natin, times 12, this is the thickness. Kasi area yung hinahanap natin. Okay? So that will be equal to 912 mm squared. So kindly resolve if this is correct. 912 mm squared. Okay? So for the net area subjected to shear, yung A and V, 140. Saan ko kinuha yung 140? Shear. Etong red line. Tignan ninyo yung red line. So yung shear natin hanggang dito. Yan. Okay? So saan ko kinuha yung 140? Wait, parang may mali. Yung 40 hanggang dito. Okay? So ito. Ito yung yan. Yan yung mag-feel. Mali itong drawing natin. So itong 40 hanggang dito yan. So yung 40 hanggang dito yan. 40 mm. Okay? Since hanggang dito. 40, ito yung mag-fail. So 40, 50, 50, that is 140. Kaya 140. Minus 2.5. Bakit 2.5? Okay? So ito, isang butas, dalawa, and then half dito. So 2.5 times 22 effective hole diameter times 12 thickness times 2. Bakit may times 2 dito? Kasi ang kinonsider ko lang dito is the upper portion. Dito lang. Remember, dalawa yan. Dito, tapos ito, shear both yan. Kaya times 2. That is equal to 2040 mm. Okay? And for the gross area subjected to shear. Subjected to shear, shear. So, yung subjected to shear, ito yan. Itong buong yan, subjected to shear. So, 140, hindi ka na magmaminus ng area ng butas. Okay? Gross. So, 140 times 12, that is the thickness times 2. Dito and then dito sa baba. That is equal to 3360 mm squared. Okay? So, meron na tayong value for A and T, A and B, A, G, B. We can now solve for the nominal strength. Ang nominal strength natin, given this equation, you just have to substitute values that is equal to 854.4 kilonewton. Kindly recheck, substitute nyo lang yung values na given dito. Okay? UBS is equal to 1.0. Okay? And then for the RN max, kasi sabi sa code that your RN should not exceed your RN max. So ano yung RN max? Given equation, you just have to substitute values since na-solve na naman natin yung RN, A and T, and then A and V. Substitute lang natin yung value. Ang makukuha natin for RN max is 864.768. Okay? So kindly solve if this is correct. So kindly check na lang. And then for, ayan, RN, na-solve natin. RN max, na-solve natin. We need to compare this. RN should be less than RN max. Is it true? 854 is less than 864. Okay. So, okay na yung RN is less than the RN max. So, therefore, your RN is equal to 854.4. Okay? So, ito na yung magiging RN natin. Okay? So, pagka meron na tayong RN, masosolve na natin yung factor tensile load using this equation. Substitute lang natin yung nasolve nating RN. Phi is 0.75. Ang PU natin is 640.80 kilonewton. Okay? So, that is for the part 1 ng black shear. So, what if we consider another path? Let's say we have here path 2, ganito. Okay, so kindly check this. 40 hanggang dito yung 40. Okay, hanggang dito yung 40. So ito yung magiging path 2 natin. So ito yung natanggal. Natanggal ito. Okay? So ito yung magiging shear natin, ito yung magiging tension natin. Okay? So you need to first solve the ANT, ANV, AGV for us to solve for the nominal strength. Okay? So ANT, consider itong green line, tension. Tension ang pinag-uusapan natin. 180, 60 times 3, that is 180 minus 2.5. Tanggal yung dalawang butas dito, tapos half dito, kaya 2.5 times 22 times 12 the thickness. That is equal to 1.5. Okay? And then, A and V, that is equal to 140. 140, mula dito hanggang dyan, 140. Since net area, subjected to shear, minus natin yung butas. So, minus 2.5. Dalawa dito, tas half dito. Kaya 2.5. Times 22 times 12. The effective hole diameter and then the thickness. That is equal to 1020. And for the AGV, that is the gross area subjected to shear, that is 140 times 12. Okay, that is equal to 1680. Okay, so after solving for the value, you just have to substitute this in the Rn equation to solve for the value of Rn. Okay, and after solving for the Rn, that is equal to 844.8, we have to compare this value with the value of Rn max. So Rn max is equal to 849.98. So saan nakuha to? Dito sa equation. You just have to substitute this value dito sa equation. Okay? So that is equal to 849.98 kilonewton. Okay? So Rn should be less than Rn max. So 844 is less than 849. Therefore, our Rn is equal to 844.8 kilonewton. Okay? Kaya ganyan yung value natin. So solving for the factor tensile load, you just have to substitute Rn in this equation. Makukuha natin Pu is 633.16. 60 kilonewton. Okay? So 633.60 kilonewton. So that is the factor tensile load considering this type of path, black shear path. Okay? And then, okay, meron pang isang path. Pwedeng maging path. So, the third path, pwedeng ganito yung magiging failure. So, ang matatanggal dito. Ito yung matatanggal. Yan yung matatanggal. So, 140 is until here. That is 40. Okay? So, ito namang path yung, sa third path, ito yung matatanggal section ng ating plate. Okay? So, the same process doon sa first part and second part natin, we need to solve for the shear and tension area. So, A and T, that is 60. Bakit 60? Bakit 60 ito? 60 yan. Yan yung 60. Okay? 60 minus, this is a 0.5 tension. This is 0.5, 0.5 since half lang dito. So that is 160 minus 0.5 times 22 effective hole diameter times 12, that is the thickness, times 2. Bakit times 2? Dito sa baba, dito sa taas, and dito sa baba. Kaya times 2. That is for the A and T. For the A and B, we have 140 minus 2.5, dalawang butas plus half, that is 2.5 times 22 times 12 times 2. Kindly solve pala this if this is correct. Kasi pinalitan natin yung 1. This is equal to 11. So kindly recheck this.
1,176.
1176. Okay? 1176. So A and B, AGV. So AGV, that is the gross area subjected to shear. So that is 140. 140 hanggang dyan times 12. The thickness times 2. Since dalawa yan, kaya 3360. Okay? So kindly solve again for the nominal strength, Rn. Kasi may napalitan na 1176. Kindly solve for the value of Rn. Maki-solve yung value ng Rn natin. You just have to substitute the value. Ilan yung Rn natin? Value for Rn, anyone. So anyone, ano yung magiging value ng Rn na natin? We have 955.2 kilonewton. Okay? And for the Rn max,
Ma'am, 970.368.
we have 970.368 or 3.7 kilonewton. Okay. So our limit Rn should be less than Rn max. So our Rn is equal to 955.2 kilonewton. Okay? So in this part, our Rn is equal to 955.2 kilonewton. So solving for the factor tensile load Pu, just have to substitute 955.2 in here. So 0.75 times 955.2. Our Pu now is less than or equal to 716. So kindly check. 716.4 kilonewton. Is this correct? 716.4. That is for the black shear path 3. Okay? So ano na yung magiging factor tensile load Pu natin? Okay, so we have considered 3 paths. Yung meron tayong path 1, 2, and 3. Meron tayong factor tensile load. So ano na yung mag-govern na computed factor tensile load natin? Ano yung mag-govern? The smallest factor tensile load will govern. Okay, so ano yung smallest value for the 3 path? So yung path 3, 713. Yung path 1 ay yung path 2, 633. Yung path 1, 640. So ano yung mag-govern? Yung pinakamaliit. So yung PU natin is 633.6. So our PU is less than or equal to 633.60 kilonewton. Okay? So the factor tensile load PU is that will govern is equal to 633.60 kilonewton. Okay? So the smallest value will govern. Okay?